Okay, let's run through the laws of indices. So every lesson you come in for indices, I will force you to memorize. You must write down. Later, right, at certain checkpoint, I'll ask you to memorize again. Okay, and then we will first 3, then we'll stop at 7, then 9. Okay, 3, 7, and 9. So these are 3 checkpoints. So the first 3 laws are the first law, multiply two expressions with the same base. When the base is the same, add up the power. So Natalie Quatolas, you can do that, okay? So what happens when you divide 2 expressions with the same base? Subtract the power. Okay, what is the third law that she cannot remember? A to the power of m raised to the power of n. When you have a to the power of m, you raise to the power of n, it gives you a to the power of n times n. Hey, this one is wrong, this one. Natalie, this one. When you multiply 2 same base, what do you do with the power, Natalie? Plus. Ayyo. I think she wrote wrongly lah. I'm sure she knows. Just that she wrote wrongly. Okay? M plus n. Okay, these 3 laws you must memorize by heart. Okay? Later, I'll test you again. Okay, when I introduce the other 4 laws to you. Okay. Okay, 3, 7, and 9. So we will start the first 3 first. These 3 must memorize. Okay, homework questions. Any questions you don't know? Any questions you want me to run through? Tell me now. I go through for you. Which one? 4 elephant. 4C is it? 4C and 4E. Okay, 4C. And 4E is it? Okay, thank you for the question. Simplify each of the following, leaving of answer in index notation. Okay, index notation. Over here. Oh, I know why you can't do this one. Hey, 4C you can do, but 4E you can do it. 4C cannot, 4E can. 4C I must teach you the law today. I'll use this one to teach you. I'll use this question to teach you, okay? Okay, we do 4E first, 4E first. How many of you wrote this? You are applying the law of indices over here, right? So your answer is 2k to the power of 6 times 3 is 18. How many of you wrote this? Okay, why is this wrong? Why? Okay, please watch, please watch. I don't know where students get this from, but many times when they see indices, right, they always apply to the algebra, they forgot to apply to the number. The number here is actually 2 to the power of 1. So what I want Dom to do is from today onwards, right, every time when there is a number involved, use a pencil, write down the power 1 there. Why? Because when you put the power 1 there, right, there is a higher chance of you getting 1 times 3 is 3. 6 times 3 is 18. If you write it this way, you know 2 to the power of 3 is 8. So answer is 8k to the power of 18. Okay? So don't understand? Next time just take a pencil, write the power 1 here, 2 to the power 1. Then if you write the 1 here, tendency is to take 1 times 3 equals to 3. Okay, can I teach you 4C now? Okay, can I teach you 4C now? Every child here knows how to do this. Every child. Okay, please watch. I'll use this one to introduce you a new law. Okay? So far you have learned from the first law, right? When the base is the same. When the base is the same, you multiply them, same base. What do you do with the power? Plus, right? I say again, same base, you multiply, same base, add up the power. Same base, you divide them, subtract the power. This is what you have learned so far. A to the power m raised to the power n, a to the power n times n. Okay, now I'm going to introduce the 4th law to you using this example. 2 cube. Can you tell me what's 2 cube? 2 cube is what does it mean? 2 times 2 times 2. 9 cube means what? 9 times 3. 9 times 9, right? Yes or no? Yes. Okay, now if Mr. were to rewrite it, tell me if the next line is the same. Are they the same? Yes. All I did was I write the 2 separately, In between them, I put a 9. So 2 times 2 times 2. So I have 2 times 2 times 2 over here. 9 times 9 times 9. 9 times 9 times 9. Okay, what's the purpose of doing this? Let's watch. 2 times 9 equals to? 2 times 9 is equals to? 2 times 9 equals to? Okay, everybody tell me what is 18 times 18. What does it mean? 18 times 18, 18 equals to? 18 to the power of 3. That's it. Okay. So over here, what do you notice? When you multiply two expressions, they have the same power. What do you do the bases then? You see the you multiply, right? First 2 times 9 is 18. So this is the fourth law I'm going to introduce to you today. Please watch. Fourth law. Okay? When you multiply two expressions with the same power, what you do is you multiply the bases. Okay? Look at law 1 and law 4. They are not the same. I say, can I emphasize? Alina, pay attention here. Okay. Charlotte, I'm going to post a video, okay? I started teaching already. I forgot you went to the toilet for so long. Must go and watch the video, okay? Okay, so law 1 and law 4, you must take note that they are not the same. Law 1 is when you multiply two expressions, same base, add the power. Okay, I say again, same base, add the power. For law 4, same power, you multiply the bases. Can you all remember that it's not the same thing? Same base, add the power. Same power, multiply the bases. Okay? Law number 5. What happens when you divide? Make a guess. What happens when you divide two expressions with the same power? What do you do with the bases then? You divide, right? So A over B raised to the power n. Okay? So when you divide two expressions with the same power, you divide the bases. Okay? Okay, girls, please pay attention to law 4 and law 5. 4 and 5, right? Many times teachers teach it this way. Okay? We teach from left to right. We teach you what the law says using examples. However, when you try to, you're being assessed, right? Most of the time teachers assess you the other way. I give you this, you must know that it's split up into this way. Okay? You must take note of that. Law 4, Law 5. Any questions with Law 4 and Law 5? Law 4, multiply same power, multiply the bases. Okay? Divide same two expressions, same power, divide the bases. Andra, okay? Sarah, can Is this easy to remember? Okay, I'll move on to law, the next one, law 6, law 7. Okay? Then after you memorize and then you try again. Okay, law number 6. I use another example. Okay, what is this equals to? Without me teaching you. 2 to the power of, okay, what is 6,000 divided by 6,000 equals to? Square root 5 divided by square root 5 equals to? Pi divided by pi. You learn, right? As long as numerator and denominator is the same thing, right? The value is always, when you divide them, is always 1. So 2 cube divided by 2 cube, we know for sure the answer is 1, right? We know for sure the answer is 1. For sure, right? Okay, let us observe the next line. 2 cube divided by 2 cube. Let's recall what we learned in law number 2. Law number 2, okay, the second law. When you divide two expressions with the same base, can you tell me what you do with the power? What? As a minor here, what do you do? Minus, right? 3 minus 3. So, can you tell me what's 3 minus 3 equals to? 0. Okay, pause for a moment. We know for sure the left hand side is 2 to the power of 0, right? We also know for sure the value of 2 cube divided by 2 cube is 1. Am I correct? So we can conclude that 2 to the power of 0 must be 1. Okay? So this is our first example. First example. I give you another example. I write in red color. Okay? Another example. What if I have 3 to the power of 4 divided by 3 to the power of 4 equals 2? Okay, let's test it again. Okay? 3 to the power of 4, divide two expressions with the same power, same base. When you divide same base, what do you do with the power? Subtract. So 4 minus 4. Right? So 4 minus 4 equals to 3 to the power of what? 0. Okay, we all know that by heart, 3 to the power of 0. Okay, let's take a minute and we ask ourselves, 3 to the power of 4 is actually the value of 81. Agree? You can punch your calculator lah. 3 to the power of 4 is actually 81, right? What is 81 divided by 81 equals to? 1. So we again know that 3 to the power of 0 must be the same value as 1. Okay? So what's so good? Okay. Without me giving you a next example, what if I ask you, girls, make an intellectual guess. What is 7 to the power of 0 equals to? 1. What is 11 to the power of 0 equals to? 9 to the power of 0? 1. Okay, so what is the next law? Guess. The next law, the sixth law is the zero index law. A to the power of 0 is equals to 1. Where A cannot be equals to 0. Okay, A cannot be equals to 0. Huh? Never take down, then you lost. Okay, A to the power of 0 is 1, yes. No. This is A to the power of 0. Means if you punch 2 to the power of 0, right, it will give you 1. Yes. Over here, right? Over here, for example, it has 7 to the power of 0. If I just ask myself randomly, 7 cube divided by 7 cube. Numerator and denominator is the same value, right? So for sure you know it's 1. Because k divided by k is 1. You know, 10 divided by 10 is 1. As long as it's same, numerator and denominator, the value show is 1. But when I apply the law of indices, right? 7 to the power of 3 minus 3 is 7 to the power of 0. So since this is always equal to 1, 7 to the power of 0 must also be equal to 1. So we know this for sure. So from here we can generalize that a to the power of 0 is equal to 1, but a cannot be 0. Okay, a cannot be 0. A can be any other value on this planet, but a cannot be 0. Okay? Okay, this is your law of the 0 law. Are you okay with 0 law? Is it difficult to memorize? Okay, can you solo one more? Yeah. 7th law. 7th one, huh? The AMS girls must listen very attentively because everything I'm teaching you, I will not repeat in AMS, okay? I will just apply it. Oh, okay. But you must copy down, okay? Yeah, you must copy down. Huh? Okay, next one, negative law. Okay, negative law. Pay attention. Okay, what is this equals to? Okay, come, everyone watch. Another example, I'm going to teach you something called the negative law, okay? Pay attention. It's not difficult if you just watch the pattern. A cube divided by a to the power of 5. Okay. You divide two expressions with the same base. What do you do with the power, somebody? Minus, right? So 3 minus 5 equals to? I don't trust you. You must trust your calculator. 3 minus 5 equals to? -2. Very good. Some of you, I ask you, 3 minus 5 equals to? 78. You write something like that. Okay? So I don't trust you. Okay, so for sure, a cube divided by a to the power of 5 is a to the power of -2. So far so good? Okay, so far so good. I'm going to write in green the same question now. Okay? Elizabeth, come over here. A cubed over a to the power 5. Wow, head so fast. Okay, pay attention first. Pay attention. A cubed. If I never teach you laws of indices, in primary school you will do this, right? A cubed means A times A times A. A to the power 5 is A times A times A times A times A. Right? So I can actually happily cancel lah, right? Cancel, cancel, cancel. So what am I left with? 1 over A squared. Yes or no? But because these two is the same question, right? So can I conclude that these two must therefore be the same thing? Because they are the same question. So A to the power minus 2 is equals to 1 over A squared. Is that okay? Is that okay? Is that okay? Can? Can? So far so good? Okay, I haven't generalized it. Now it's just something that we observe. A to the power negative 2 is equals to 1 over A squared. Okay, let's try another one. Okay, let's try another one. Let's try another one. Another example. Another example. Let's say I do another alphabet B. Okay, B to the power of 4 divided by B to the power of 7. Okay, let's take a look. What do we have? Let's apply the law of indices first. B equals to B to the power of 4 minus 7. What is this equals to? I don't trust you, but calculator please. 4 minus 7 is negative 3. Very good. Somebody says it's what? 6,000. It's wrong. It's not 6,000. Okay? 4 minus 7 is negative 3, not 6,000. Okay, so this is B to the negative 3, right? Let's make a prediction. What do you think this is in positive index?
1 over B to the power.
You predict, right? You predict it's 1 over BQ, right? Okay, let's test it out to see if it's true. Okay, let's test it out. So B to the power of 4, I write in green now. B to the power of 4 divide B to the power of 7. So B is B times B to the power of B times B times B times B times B. B to the power of 7, I wrote too many times already. 1, 2, 3, 4, 5, 6, 7. Happily cancel, 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 cancel. Charlotte, now pay attention. Almost there, almost there. So this is B times B times B is B cubed. So since these two questions is the same, I know that these two answers must also be the same. That tells me that B to the power minus 3 equals to 1 over B cubed. Okay? Yes.
The answer like B minus B to the power of negative 3.
Yes, you can. Yes, you can. Can. But what if the answer question asks you to leave your answer in positive index? Then you must die write this one. If they never say, doesn't matter. You can leave it. Okay, so if you generalize this, A to the power of minus n equals to, what is this equals to? 1 over A to the power of n. Very good. 7th law. Okay? 7th law. A to the power minus n equals to 1 over A to the power of n. So this is the negative index law. Okay? Okay, before I pause the video, I just give one example. Just one example, okay? I want you to convert this following into positive index. Okay, convert this to positive index. What do you have? X to the power negative 2 over y to the power negative 3. Convert this to positive index. How do you do it? I see Ellie doing this. Ellie must help me wake Rachel up first. Rachel, very comfortable. Take her up first. Okay, Rachel, hang in there. Okay, a bit more, my dear. A bit more. Okay. I see Ellie doing this. Oh, I know she's thinking. Either that or she's trying the new TikTok move. I don't know. Okay, but do you observe something? Do you notice the A, right, is the same as A over 1, right? Correct. Right? A is the same as A over 1. Right? Do you notice when you want to get rid of the index, right? Do you notice you flip the numerator and denominator like what Ellie is doing? So we got 1 over A over n. Do you all see that? So there is a trick to doing this. Very simple. x1 negative 2, right? Numerator become denominator. So just change the position, become denominator, the index will become positive. So if it is y to the power negative 3 is in the denominator, y become positive index. You just flip the position, the negative sign will disappear. That's one way of remembering. Okay, that's why Ellie was doing this. Correct, Ellie? Okay, Katie can pause the video. Okay, okay, girls. Okay, pay attention to the last bit of the lesson. Give me a bit more time. I'm done with the last 2 laws. Okay, at least on Thursday when you do the HBL lesson, you see the fractional law, which is the hardest one. Hopefully, you have no trouble with it. Okay, because at least I taught you now what it is first. So on Thursday, the HBL lesson, if you don't understand the SRS lesson, you still can refer to this lesson. Okay, Sophie's video, and then you watch and then you learn. Okay, fractional indices. What happens now when your power is a rational number? What happens if your power is a rational number? We have worked with integers before. Come. Here, pay attention. Come watch here. Anqing, come watch here. We have worked with positive numbers before. We have worked with the number, what happens when your power is positive? What happens when your power is 0? A to the power of 0 is 1. What happens when your power is negative? Negative number, a to the power of negative n, right? The negative law of indices, we have already done that. So this is the last part that you have not worked with yet. What happens if your power is a fractional number? Okay, wait, I'm going to guide you to it. This one is a bit difficult. Okay, please pay attention. What is 5 to the power of 1/3 equals to? I don't know. Let's say A is 5 to the power of 1/3. Let's assume, is that okay? Let A be equals to 5 to the power of 1/3. Is that okay? If Mr. were to cube the left hand side, if I cube the left hand side, am I right to say that I can cube the right hand side? It means I can cube this. 5 to the power of 1/3 times 5 to the power of 1/3 times 5 to the power of 1/3. Agree? Yes? What is this equals to then? When you multiply two or more expressions, the base is the same. Base is the same. What can you do with the power? Can you tell me? Plus, right? 1/3 plus 1/3 plus 1/3 equals to what? I don't trust you. I don't trust you. What is 1/3 plus 1/3 plus 1/3 equals to? Believe it or not, it's 1. Okay, punch your calculator. So let's pause for a moment. If A cubed equals to 5, okay, what is A equals to then? Sarah, if A cubed equals to 5, what is A equals to? If A cubed equals to 5, A is equals to what? We did this in our the gym class or something like that. Make A the subject of the formula. If A cubed equals to 5, A equals to what? Cube root of 5, right? Yes or no? Right, okay, let's pause. Okay, come watch here. A is 5 to the power of 1/3. A is also cube root of 5, which is what Sarah says. That means they are the same, right? Got both are A, right? I can put them together, right? So we can conclude that, what can we conclude? 5 to the power of 1/3 is actually the cube root of 5. Okay? Okay? One more example, then we can conclude it. Another example. What is, let's say, 3 to the power of half equals to? What is 3 to the power of half equals to? I don't know, right? I let B be 3 to the power of half. So what happens if I square both sides, that means 3 to the power half and 3 to the power half, right? So multiply two expressions with the same base. What do I do with the power? I can add them, right? So half plus half. Half plus half equals to what, somebody? 1, right? If B squared equals to 3, what is B equals to, somebody? Square root 3, right? By right should be plus minus, right? By right it should be plus minus. By right. Because we still have told you b square, your power is even. You take the root of it, you will always have plus minus. Yes? Okay. However, for this question, for this situation, right? Can you tell me, is it positive or negative? Is it positive or is it negative? Which one? Is it positive or negative? Which one? Positive. How do you know positive? This one is rejected. Okay, this is the answer. Okay, why? Please watch. When you first start learning mathematics in primary school, right? No, not even primary school, in kindergarten, K1. You start learning how to count. The number 5, positive or negative? Positive, right? The number 3, positive or negative? I never tell you whether positive or negative. Just because of the number 3 in front, right? There's no sign. By default, you take it to be positive. By default. You first learn mathematics this way. So 3 to the power half, right? By default, you see there's no sign in front. So by default, it is also positive. That's the reason why it's positive. Are we clear? Okay. So now, since b is 3 to the power half, since b is also positive square root 3, I put them together, right? Am I right to say that I have 3 to the power half is equals to the square root of 3? Okay? So now, if Wisdom were to ask you the next question, are you able to generalize it? Okay, Kat is not here. Kat is quite good at generalizing stuff. If I have a to the power of 1 over n, what happens is 1 over n. Can you tell me what is this equals to? Give you a clue. See, if you have 5 to the power of 1/3 cube root of 5. When it is 3 to the power of half. No, this is square. The 2 is the same. Can you see? So if a over 1 over n, this is equal to nth root of a. So this is our 9th law. Okay? Sorry? Okay, n. Okay? Hey, 1 over n. Nth root of a to the power 1 over n is actually equals to the nth root of a. Nth root of a. Okay? Kat, you miss your chance to generalize this, but I think you will get it. Okay? Yes, go. What if there's a what? Here is it. Numerator.
Oh, sorry.
The name is the denominator. You think of denominator. Okay, you're talking about numerator, is it?
Yeah.
Okay. That's the next law. Okay. Our 8th law, fractional law of indices. Okay, Kat, you were not here. So 8 power 1 over n is the nth root of a. Okay, girls. Okay, I just taught this to the A Max girls. Okay, this is called what for A Max girls? This is called what for? Surds. Okay, as long as you got this symbol, right? This is called surds. In Emacs, sometimes you call surds. If not, there's also another name you give to it rather than the word surds. Radical form. Radical. Okay? Radical form means this one. Okay? It means it's same thing. Radical form. Okay? Means the moment you have the square root sign appearing, we call it radical form. Okay? Chloe, okay, you went toilet, see, you come back, wow, 1 law over. Moral of the story, don't anyhow go toilet during lesson time. Okay, you go toilet 1 time, you come back, you miss 1 law already. But it's okay. That's why we video now, you didn't lose anything, you can watch it. Okay, last law. Hannah so far, okay? A lot, right? Last one, 9th law, last one. Okay, last one, Dom asked a question. Dom asked, what if the power is not 1? What if the power is something else? Okay, please watch. We have learned that a to the power 1 over n. Dom, what is this equals to? The nth root of a, right? The nth root of a. Okay, nth root of A. Okay, don't ask what if there is a numerator. Okay, I'm going to introduce this to you. Last one, okay? The ninth law is also a fractional indices law, but it has two versions. I will tell you which version I prefer, okay? What if your power is not 1? What if your power is m over n? Okay? Basically, am I right to say that you can write it this way? Yes? Am I right to say that they are the same thing? Yes? Double check your third law. Third law. A to the power of something, raised to the power of something. So 1 over n times m equals to m over n. So they are the same thing, right? Okay? So what happens if I write it this way, okay? A to the power 1 over n is actually equals to what? Nth root of A. So nth root of A. So this is one version. Okay? This is the version that I like. I like this version a lot. Okay, second version, I can also write it this way. Do you agree with me? I can write it this way. They are the same thing. Instead of writing 1 over n to the raised to the power m, I can write m raised to the power 1 over n. Because n times 1 over n is equal to m over n. Okay, what's the purpose of writing it this way? If I write it this way, something to the power of nth root. So it's the nth root of a to the power of n. They are the same. Okay, got two versions. Mr. prefer this version. A-Maths girls must learn this version is better. Okay, because you shrink the number first and then you work with it, it's easier. Okay, I give you an example how to apply this law, okay? Okay, let's take a look. One last example and I'm done, okay? So okay, next lesson, so I give you chance to show all 9 laws, okay? 27 to the power of 2/3, what is this equals to? Okay? Let's try the second version first, is that okay? Second version first. Okay, second version says, this is 27 to the power of 2, right? Then raise the power 1/3. Yes or no? Yes or no? 27 square. Girls, how many of you here knows what is 27 square? I don't think you all know, right? You have to punch calculator. What is 27 square equals to? 700 and what? Okay, then what happens when you cube root it to the power of 1/3? You cube root it becomes what? How many of you know what is cube root of 729? 9. But how many of you actually really know? It's 9, but not many of you know, right? Okay, now let me show you why I prefer the first method, okay? The first method is easier because you shrink the number. Instead of blowing up the number first, right? This version says you shrink the number first. So 27 to the power of 1/3 raised to the power of 2. You write it this way better, okay? 27 to the power of 1/3 means cube root of 27, right? Every child here knows what is cube root. Cube root of 27. Charlotte, what's cube root of 27? Cube root, my dear, cube root. Cube root of 27. 9 times 9 times 9 is 27, man. Try again. Come on, you can do it. Something give you 27. Three, okay? Hey, the cube root of 27, you all know is 3, right? Yeah. You all know, right? Charlotte, don't scare me, huh? 3 squared is what, everybody? 9. 3 squared is 9, not 6, huh? 3 squared is 9. Can you see the answer is the same? But this version, right, the first version is better because I shrink the number first. Can you all see what I see? Can you see what I see? I hope so. This version is better. So the last law, 9th law, is Dom, the 9th law, because you asked m over n. So the last law, so this one is a to the power of, it's actually the nth root. Okay, this version or the other version? Both versions. Okay, 9 laws of indices. Okay. Okay, Katie can pause already.